Welcome back. This video is part 6 of a 9-part series on completing the square. In this video, we'll discuss how to complete the square for cases where the linear coefficient is either odd or fractional. I suggest that as you watch this video, you take your own notes. Get a pencil and some paper, and let's get started. Previously, we've completed the square for problems with even linear coefficients. In this example, the linear coefficient is 2. We call this coefficient b. b is 2 and b over 2 is 1. We can then use the perfect square pattern to complete the square, which is something we've done many times. Now what happens when the linear coefficient is odd, in this case 3? If we try the same procedure, b is 3 and b over 2 is 3 halves. And when we use the perfect square pattern, we get an equation containing fractions. So today, we'll discuss how to solve these kinds of problems with fractions. Let's talk about how to add fractions. Say we have 5 plus 16/9. Our overall strategy is to match the denominators. 5 doesn't have an apparent denominator, but it can be written as a fraction. So the first step is to write 5 as the fraction 5 over 1. Then we multiply this new fraction by 1 over 1. We can do this because a value isn't changed when multiplied by 1. We want to match the denominators, so we're going to write 1 in a special way, namely 9 over 9. 5 times 9 is 45, and 1 times 9 is 9. So we have 45/9 plus 16/9. Now that the denominators match, we can add the numerators and keep the common denominator. In the end, we get 61/9. Let's do an example with an odd linear coefficient. We start with x squared plus 7x equals -12. We compare it to the perfect square pattern in the blue box. In this equation, b equals 7 and b over 2 is 7 halves. When we plug those values in, we get x squared plus 7x plus 7 halves squared equals x plus 7 halves in parentheses squared. According to this pattern, we can add 7 halves squared to both sides and write the left-hand side as a perfect square. After doing that, we get x plus 7 halves in parentheses squared equals -12 plus 7 halves squared. We take the square root of both sides and include a plus or minus on the right-hand side. The square and the square root cancel on the left-hand side, and we get x plus 7 halves equals plus or minus the square root of -12 plus 7 halves squared. The -12 and the 7 halves squared are both under the square root. To solve for x, we then move the 7 halves to the other side. And when we do that, it becomes negative. We can reorder the terms, and when we do so, we get x equals -7 halves plus or minus the square root of -12 plus 7 halves squared. The two solutions are x equals -7 halves plus the square root of -12 plus 7 halves squared, and x equals -7 minus the square root of -12 plus 7 halves squared. It's likely that you'll be asked to combine the terms by adding fractions. First, 7 halves squared can be evaluated by squaring the numerator and squaring the denominator. So 7 halves squared is equal to 49 over 4. -12 can be written as a fraction -12 over 1. We can multiply -12 over 1 by 1 over 1 without changing its value. To match the denominators, we write it as 4 over 4. After that multiplication, we get under the square root -48 over 4 plus 49 over 4. Now that the denominators match, we can add the numerators and keep the common denominator. That value is 1/4. So we have x equals -7 halves plus or minus square root of 1/4. The square root of 1/4 is the same as 1/2. We can now see that these denominators match. So finally we get x equals -7 plus or minus 1 over 2. The first solution is x equals -7 plus 1 over 2, which is -6 over 2, which is -3. The second equation is negative 7 minus 1 over 2, which is negative 8 over 2, which is negative 4. So even though fractions were involved, the answers turned out to be whole numbers. Before we get to fractional coefficients, let's discuss dividing fractions. Let's say we have the fraction 1/3 divided by 4/5. The general strategy is to multiply by the reciprocal. We bring up the fraction in the denominator and multiply it to the numerator. But when we do this, we also need to flip this fraction, which is called the reciprocal. We can then multiply the numerators and then multiply the denominators, and we get 5 over 12. What happens when you divide a fraction by 2, such as 1/3 divided by 2? We can write 2 as the fraction 2 over 1. We can then multiply by the reciprocal. We bring up 2 over 1, flip it, and then multiply. We then get 1/6. In general, dividing a fraction by 2 doubles the denominator, so 1/3 became 1/6. So let's do an example with fractional coefficients. We start with 3x squared plus 7x minus 100 equals 0. To complete the square, we have to match the pattern x squared plus bx equals some number. First, we move 100 to the other side, and when we do so, it becomes positive. The leading coefficient is 3, and so we divide every term by 3. In the first term, the 3's cancel. In the second term, we get 7 over 3, and the remaining term is 100 over 3. So we get x squared plus 7/3 times x equals 100/3. According to the perfect square pattern, b equals 7/3, and using the rule that dividing by 2 doubles the denominator, b over 2 is equal to 7/6. We plug into the pattern. If we add 7/6 squared to both sides, we can write the left-hand side as a perfect square. We get x plus 7/6 in parentheses squared equals 100/3 plus 7/6 squared. We take the square root of both sides and include a plus or minus on the right-hand side. The square and the square root cancel, and we get x plus 7/6 on the left-hand side. To solve for x, we move 7/6 to the other side, and when we do that, it becomes negative. We get plus or minus square root 100/3 plus 7/6 squared, all of that under the square root, then minus 7/6. We then reorder the terms as is commonly done. Now, at this point, if you just need a value, I would suggest that you use your calculator to find the values from these equations. But if you're asked to combine terms, then you'll need to do additional work. Now, I'm going to show you how to combine the terms. We start by replacing 7/6 squared with 49 over 36. We multiply 100/3 by 1, but in the form 12 over 12 so that the denominators match. When we do that, we get under the square root 1200 over 36 plus 49 over 36. Now that we have a common denominator, we can add the numerators. When we do that, we get square root of 1249 over 36. This can be rewritten as square root 1249 over 6. So x equals negative 7/6 plus or minus square root of 1249 over 6. The denominators match, and we get negative 7 plus or minus square root of 1249 over 6. The two solutions are x equals negative 7 plus square root 1249 over 6, and negative 7 minus square root 1249 over 6. As you can see, the inclusion of fractions can add quite a bit of work to the solution. Now you try. Complete the square and solve for x. Pause and try these two problems. The first problem is 2x squared minus 6x plus 2 equals 0. So the first step is to move the constant term to the other side. When we do that, it becomes negative. We see we have a leading coefficient 2, so we divide every term by 2 and we do some cancellation. And we end up with x squared minus 3x equals negative 1. This matches our perfect square pattern, so we can complete the square by adding negative 3/2 squared to both sides and writing the left-hand side as a perfect square. So we get x minus 3 halves in parentheses squared equals -1 plus -3 halves squared. We square root both sides and put a plus or minus on the right-hand side. On the left-hand side, the square and the square root cancel, and we get x minus 3 halves equals plus or minus square root -1 plus -3 halves squared. We move the -3 halves to the other side, and when we do that, it becomes positive. So we get x equals plus or minus the square root of -1 plus 9/4 plus 3 halves, where -3 halves squared is the same as positive 9/4. We can then multiply -1 by 4 over 4, so we have a common denominator. And inside the square root, we have -4 plus 9 over 4, which is 5 over 4. And then if we take the square root of the numerator and denominator separately, we get x equals plus or minus the square root of 5 over 2 plus 3 halves. We have a common denominator, and also we're going to switch the order of the terms, and we get x equals 3 plus or minus the square root of 5 over 2. So our two solutions are x equals 3 plus the square root of 5 over 2, and x equals 3 minus the square root of 5 divided by 2. Our second problem is 5x squared minus 9x minus 135 equals 0. So the first step is to move that -135 to the other side, and when we move it to the other side, it becomes positive. We see we have a leading coefficient 5, so we divide every term by 5. We do some cancellation where we can, and we get x squared minus 9/5 x equals 27. This is our perfect square pattern. B is -9/5, b over 2 is -9/10. So we add -9/10 squared to both sides. We can write the left-hand side as a perfect square. So we get x minus 9/10 in parentheses squared equals 27 plus -9/10 squared. We square root both sides and include a plus or minus on the right-hand side. On the left-hand side, the square and the square root cancel, and we get x minus 9/10 equals plus or minus the square root of 27 plus -9/10 squared. We move the -9/10 to the other side, and when we do that, it becomes positive. And we get x equals plus or minus the square root of 27 plus 81 over 100 plus 9/10, where -9/10 squared is the same as 81 over 100. We can then combine terms with a common denominator by multiplying 27 by 100 over 100. And when we do that, we get a common denominator of 100, and we can add the numerators. And when we do that, we get x equals plus or minus the square root of 2781 over 100 plus 9/10. We can then, the square root of 100 is 10, so we have a common denominator, so we can combine the numerators, and if we change the order, we get x equals 9 plus or minus the square root of 2781 divided by 10. So our two solutions are x equals 9 plus the square root of 2781 divided by 10, and x equals 9 minus the square root of 2781 divided by 10. That concludes this lesson. If you liked it, then click the like and subscribe buttons below. In the next lesson, we'll complete the square symbolically without any numbers. And I'll show you the connection between completing the square and the quadratic equation. See you in the next video.